Okay there, welcome to our next lesson in Creo. In this lesson we're going to be taking the parts that you've been modelling, being the coupling, the retaining clip and the pin, and we're going to learn how to assemble them together to create the actual coupling link together. So the first thing to do is to make sure that you have all these parts all in the one folder, and then we're going to create an assembly within that folder as well. So set your working directory to make sure it's the same folder you have these parts saved in. Good file management. Okay, across to Creo, and you can see here's a finished one. So we'll create a new one, File, New. And this time, rather than clicking on Part, we're going to click on Assembly. I'm going to name the assembly, not retaining, sorry, coupling link, coupling underscore link. It's a link in a chain. Okay, okay, and we've got a blank page. I might just turn my planes on so I can see them. Now before we bring anything in, I just want to show you this. If I hover over here, you'll see it's called the front plane. It's important that we realise that when we bring our first object in to the assembly, we need to ensure that the object remains parallel with these planes. If that's the front plane, that's the plane that I'm going to be looking through for the front view of my drawing. And it's important to make sure that the object remains at 90 degrees to it, otherwise we won't see the true shape of it. Either way, let's go to Assemble, tab up here. Let's go Find. First of all, let's insert the coupling. Now, you can see here that I've brought this coupling in, but it's not orientated in the correct position. I don't want to have the object sitting down, being in a sitting down position on its edge. So what I need to do is I need to rotate this coupling link around. Now you see here we've got this dynamic ball looking thing, and when the colours on all these edges and so on, all these control handles are coloured, it means that we can use them to move things around. So the first thing I'm doing, I'm going to grab this red one here. I'm simply going to twist it almost 90 degrees. Now there's no guarantee that's exactly 90 degrees, and there's no way of really controlling that with these move handles. So I'm just going to do it approximate. But then you'll see up here it says at the moment that there are no constraints applied to fixing this object in place. So what I want to make sure here is that this top face of my coupling, if I just select it, and if I've got my planes turned on, you can see here that I'm going to actually select the front assembly plane. You can see it highlights there, front. So I select that one, and straight away it's changed from automatic to partially constrained, and it says that it is at a normal. Now what normal means in graphics speak is 90 degrees. It means that this face that I just selected is now a constraint put on it to be at 90 degrees to that plane that I selected. We can see that in detail if we open up the placement tab. You can see here this is the first constraint. It's called normal, and there's our two planes, 1 and 2, that we selected for them to be at a normal. You can of course select other ones like coincident, which will make them parallel with each other, angled, parallel, and so on. But we want ours to be normal. At this point, you can see it says it's partially constrained. While the object's partially constrained, these drag handles will appear. So what I'm going to do now, I'm going to click New Constraint over here in the Placement tab, and then I'm going to choose Fix Constraint, which means the whole object is fixed in space. You'll notice it's now changed to fully constrained. Our handles disappeared, which means that it's now got enough points of reference so it will not move away from this current position. Okay, let's click OK. First one's brought in. Now after you've brought your first piece in, there's probably no need to have those planes on, so I'll just turn them off. And then we can start assembling the rest of it. So of course the next one thing to bring in would be the pins. Click on Assemble, click on Pin, and I like to use these axes here. You can also use the center ball in the center. And of course here's your options to spin and what have you. So generally when I see something cylindrical, I'll always go for a cylindrical surface that it needs to, we used to say, center axes with. So I'm going to choose this inside cylindrical surface here. and then I can choose any of these cylindrical surfaces, because it doesn't work on the actual surface there, it's working off an axis. So even that one will do. Now if we have a look, if we spin it around, you can see it's now centered, if you like. And then the last thing to do is I could move this down closer, and you can see that I can't move it left and right because they're greyed out now, because it has a centered sort of axis constraint onto it. The only way I can move it is up and down and rotating it around like so. The next constraint I can place on just by simply clicking this face here, rotate it around, and then I can just select the surface underneath here like so. You see it's defaulted to distance, so rather than it being distance, we can set up here in our constraints. I've got distance, angle, parallel, coincident. Coincident, you can see the two faces are actually touching each other. Click on coincident, and then therefore we have that held in place. Fully constrained, our ball's disappeared, click the tick button, and repeat that same process for the next one. Assembly, pin, move it roughly to the right position, cylinder to cylinder, face to face, and change it from distance to coincident. Pretty simple. Now if you do happen to make a mistake, you can go back and edit things here by clicking on the placement tab. You can see there's my first constraint, there's my second constraint, and you can change the different surfaces, and you can delete constraints as well. But we can see it's for the constraints in the right position, so I'm going to click the green button. Second last thing, I'll bring another piece of coupling in. And this time I'm not going to spin it, I'm just going to choose this inside of the cylinder here. Doesn't matter, it can be any of these cylindrical surfaces because they'll have the same center. Use my move tool, bring it up. And most of the time the computer's smart enough to work out that this part and this part are actually going to join, but I'm just going to make sure. So I'm going to zoom in here and select that cylinder, and then lastly, oops, I accidentally hit the center mouse button then. Okay, and you can see here, I accidentally hit the center mouse button which completed it, but the coupling, that second coupling I brought in over the model tree over here, has got a little square beside it. The little square means that it's not fully constrained. So what I'll do is I'll just right click on that, left click, right click, edit definition, and I can finish it off the constraints. So I'll just spin him around, that surface there, that needs to join or mate with that one there. Not at distance, once again change it to coincident. Fully constrained and tick. Looking good, one part to go, being the retaining clip. Similar process inside of a cylindrical surface to another cylindrical surface. You can see the object's disappeared inside here, so these handles are quite handy. Just going to check this other one at the other end, make sure it is constrained. And then lastly, we want the bottom of that retaining clip to go on top of the coupling here. 1 and 2, and it's guess coincident this time, which is correct, and tick OK. Down the bottom here with our preset views, we'll just click on isometric, and if we've done everything correctly, if I click on front view here, we should see ourselves looking in at 90 degrees. Obviously you can choose left, right and top and so on, and we have correct alignment. Okay, now you're ready to render and start creating some drawings.